world, in the art world. Ombre sounds made up is what it sounds like. Alright, maybe at the end of class, because I'm worried that my recording won't last for the whole time. So first off, Amara, this is mainly for you because we're mad at you because you're on vacation. But also for my, blue students. Sorry, I looked down at my socks. I'm now wearing socks to indicate what color of day it is. So it's a green day, so I have green socks on today. So, for my blue kids who are at home, hopefully you watch this. Let me know if you have any questions as we go. Today we're talking about how to graph quadratics. Sorry for that capital H right there. I should have put like a quotation around that or something. How to graph quadratics in standard form, because we've gotten way far away from standard form. And first thing I should do is plug my YouTube channel. I am making help videos for you guys. So if you send me questions and ask for help, I will probably potentially just record a video and send it back to you. So yesterday, as I had my blue kids here, we did a couple help videos with completing the square of this was a nice square, and then we did another nice square, and then a not so nice, complete the square. So if you need help, please feel free to email me, take screenshot of stuff, exactly like what I'm doing right now, which this will be a video inside of a video inside of a video, which is kind of cool. Videoception. So there is yesterday's Mr. Hudson. It's like we're time traveling. Yeah, send me questions if you need to. Go check my YouTube channel for help videos if you need. Any questions before we dive in? Oh yeah, we're going to play Desmos later. Which for any of my people at home, the Desmos activity will still be alive even after this recording. I will leave it open. Yes. No. And if somebody would like to volunteer for a job, my YouTube could definitely use someone who knows how to sort and categorize things in YouTube. It is just one giant page of videos. So, right now, it's just a bunch of videos. Keep scrolling. Years and years old. During the pandemic, I made one about toilet paper, and I, almost had a beard. And I don't grow a beard. I, can't. So, yeah, lots of... I have some really old videos of, me doing math with, stuff out in my yard. I mean, these aren't very old, but they're, last year. I've got a lot of videos because I record, every class. So, yeah. This year, I think, looks a little bit cleaner because it's not such a bright background. Ah! I did not mean to move my recording screen. I know, we're almost at 250. I think that actually went down from the other day. I think somebody was like, nope, I don't like this anymore. Alright, this might have been why, because we started doing really difficult math. I gotta scooch this over so I can see it on my screen. So let's write this down. These are some problems we've been having some challenges with. We're gonna do a couple review problems, then talk about new stuff. So really quickly, if we were talking about trying to complete the square in a problem such as this, what would we need to do first? Oh, I also just wanted to review the form that they use in KA. So Khan Academy, right? So the KA form, and I'm going to head our notes once we start new stuff, but the KA form of completing the square is x plus or minus, they call this C inside of there. I know you guys can't see what I'm writing right yet. Equals D.
You named it after me. Thank you.
So that's our KA form. I don't really care what you guys call it, but when Khan Academy asks you to put it in the form that looks like this, it's slightly different than what we're used to calling our vertex form, because our vertex form was still quadratic, right? So it was still equal to 0. So vertex form, what we were used to writing out, was essentially y equals, if we had a leading coefficient, a times x minus h squared plus k, all equal to normally 0, unless k is something else. Normally we had, not k, sorry, unless y is something else. So that's where vertex form is slightly different than the Khan Academy form. They're constant being on the other side as opposed to the same side. Biggest difference. So if we wanted to take negative 2x equals x squared minus 6 and get it into this form, x plus or minus c equals d. What do we need to do? Kayla? So make it quadratic, right? Make it equal to 0. So push this negative 2x over to the other side by adding 2x to both sides. So this will be 0 after I add the 2x, and we get x squared plus 2x, writing these down in the correct order, minus 6. Now, it acts, because they want this on the other side on its own, we could push the 6 off of here. But if we're trying to create like perfect square form, if we're trying to complete the square, okay, most of the times when I solve this, I keep the constant over here. Let's go ahead and do it the other way. I'm going to go ahead and push the constant to the other side. So what I'm going to do is flip this around, put my equal 0 on the right side, and then move my 6 over. So I get left with x squared plus 2x equals a positive 6, because if I add it to both sides. And the reason I'm going to do this is to be more similar to what Khan wants us to do. It's just another way. It's not the way that I normally default to, but it works just as well. Then we said yesterday, guys, I'm going to start using the word yesterday as in meaning the last time we had class, because it's just easier. So like we said yesterday, what do we do here? What do I know goes here? But why? Half of b, right? So half of b always goes here. It's 1. The issue is, and normally I leave a little bit of space between here. The issue is that when I do that, I'm going to write in a really light color, I would get x squared plus 2x plus 2. Ah, 1 times 1 is 1. Thank you. I'm glad we're awake. So the issue is right now over here, I don't have anything. So if I need to compensate for this plus 1, we have to add 1 on both sides. I don't know if this yellow is quite dark enough. So what we actually now have is x plus 1 squared. Yay! After we added the plus 1 on both sides. So we have x plus 1 quantity squared equals 7. Oh, thank you. Sorry, I literally couldn't hear what you guys said. Now, the other way we could write this is x plus 1 squared minus 7 equals 0. Why do we use vertex form? Why do we normally have this equal to 0? What do we do with this? Yeah, -1, -7. So if you're in the Khan Academy form, which I bet there's a better name for this form, here's the kind of fun thing. I always try to give like benefit of the doubt, which if you don't know what that means, best way to explain it is like, if I think you're wrong, but I want to try to make an argument for you to be right, right? That's like the benefit of the doubt. So I doubt you, but I'm going to try to give you some benefit. So if I try to give benefit of the doubt to the Khan Academy form, opposite, my vertex is -1, -7. That's the only thing where I think like, well, that's kind of nice that I just take the opposite of both of them. As opposed to in vertex form, opposite of h, and then we just take what k is, right? So, you know, different strokes, different folks. Or I don't really know what that saying means. I think that was an old TV show way back when. But all right, so that's the vertex. Great. What else can we do with this Khan Academy form? Why do we think they want it like this? I'm going to even put a post-it and cover up the other form beneath it, the vertex form. Why would we work with that form? What else do we need if we're trying to solve the equation? Or if we're about to graph equations, what else do we need? Zeros, right? What the x, right? The x are zeros. So I can square root both sides, and that gets x plus 1, plus or minus radical 7. So then my x values are -1 plus or minus radical 7. So in this form, we can then go from that form to solving our zeros. So, because I didn't label it anywhere, those are our zeros. Questions on that? Now I'm about to need you guys to be really honest, because we're going to look at a couple more of these, and I need you to tell me if you want us to solve them or not. And that's like tough, because if you think you're the only person, then that's like a little scary. But guys, I promise you, if you want to see it solved, somebody else also does. So same like type of problem. Would you like to see this one solved? And I'll go back through them. This one or this one. Any of these are the same type of rewrite it in that form. Yeah, the only difference really is this one has a leading coefficient of 4. This one has a leading coefficient of 2. And then we're moving on to new stuff. So do we want to see any of these, especially like one with a leading coefficient? Should we do this one? Yeah, let's do this one. So let's go ahead and write down 4x squared plus 20x plus 25. What should we do? Come on, guys. You have the opportunity to tell your teacher what to do. Somebody tell me what to do. Take half of b. I don't necessarily disagree with you. Yeah, so what they tell us is we have to match the form of x plus something squared equals something. And there's no coefficient out here. And there's no place for a 4 out here. So if we divide the whole thing by 4, 0 divided by 4 doesn't change. So I really would just get x squared plus 5x plus the only place where it gets a little tricky, we're just going to leave it as an improper fraction. Okay. Yeah, if we want to solve it like the one we just did, and differently than my normal habit, sure, I like that. I'm going to leave a blank over here, though, because I know eventually I'm going to put a constant there. So this 25/4 becomes negative 25/4. I am going to skip my section. I forgot to do that last time, but if I come down and I start to set up x plus something squared, what should this something be, we said? No. Yes, but no. Don't use the decimal. Use the fraction. Trust me on this. Because to figure out what our c is, remember that c is always b divided by 2 squared. Wait a minute. What's 5/2 squared? 25/4 is what we want right here. Oh, we had that. This is perfect square already. X squared plus 5x plus 25/4 is perfect square already. So we actually didn't need to move this 25/4 off of the left-hand side. If I never did that, I would just have this. Right, and this is my x plus 5 halves quantity squared. So really, this is equal to 0. Right, there is no constant needed to be added, because if I come up here and I add the 25/4, and I can write it out since I already wrote this out. If I add 25/4, my right side just becomes 0. It's kind of cool. That worked out. So it looked messy, like it wasn't going to work out, and it did. So from here, we could figure out our vertex is negative 5 halves 0. And we could solve our zeros by taking the square root of both sides. Wait, I only get 1 0? What's that mean? The vertex is... Oh! The vertex is our 0. Oh. Tricky. You're like, no, not really. Do one more. 2x squared minus 9x plus 7. Let's see if this one's nice or if it comes out weird. 9 kind of scares me right off the bat, but we'll see. I'm intentionally not showing mine. I want to give you guys a moment to try this on your own. Wait. So, just for fun, we're kind of taking the different route today of pushing the constant over to the other side. So if I did that, I'd have negative 7 over here. If I divided everything by 2, don't use 4.5. Use 9 halves. Now, half of b. Okay, yeah, 9 over 4, but we got to make sure we bring the negative. So negative 9/4. So if you're in the habit of writing x plus, make sure that you give that negative. To have a fraction, you double the denominator, right? To half a fraction, we double the denominator. Now my constant, if this was true, which we're making it be true, would need to be... Where's my green? There's my green. What is negative 9/4 squared? Well, yeah, 81/16. So we have to do that to both sides. Now, negative 7 halves, if I think about it in 16ths, negative, well, this would be times 8. So 7 times 8, 56. So really, we have negative 56/16 plus 81/16. So 81 is obviously bigger than 56. So then we got to do the difference between them. So 5 gets us to 61. 25, I think. Somebody should check my math for sure. This is one of the messier ones that we've dealt with. Was that a Mr. Ed noise? Wilbur. You guys probably have no idea what I'm talking about. Mr. Ed was a TV show with a talking horse. You're like, that doesn't sound fun at all. So this tells us, we can pause for a moment and say, okay, vertex is, oh, opposite, opposite, right? We said when it's set up like this, we do opposite, opposite. So positive 9/4, negative 25/16. Okay, this is a little ridiculous. 25/16 could be reduced. No. Well, we could write them both as decimals if we want. Negative. No, positive. 2. Sorry, I shouldn't do this. Positive 2.25 and negative 1 9/16. Thinking. I don't know if 9/16 reduces. Whatever. You can write that however you want. They're weird numbers, right? There's like, they're not terrible numbers, but they're kind of weird. Do we have any questions how we got to this point of getting our vertex? So then, 2.25 is not that bad.
It's not bad, but it's just annoying.
And 9/16, I think that actually comes out to a not terrible decimal.
Okay, well, you can say whatever you want. I think it's annoying.
I know, you can say whatever you want too. I didn't disagree that it's annoying. Yeah, it's annoying. I agree with you there.
Okay.
I was talking with one of our 7th graders about how you and I used to have those like math fights during Math 8.
Yeah, I'm done with that.
But it's so fun. Wow, you lost some passion. Square root. I don't want to fight with the teacher anymore.
You're not supposed to fight with the teacher.
That's what society wants you to think. Positive or negative? What's square root of 25/16? 5/4. It gets nicer. When we square root it, it gets nicer. And so then x would equal, okay, so a positive 9/4, right? Sweet. Okay, positive 9/4 plus or minus 5/4. Oh, well, that's kind of nice. So really, that's like 2.25. Hey, look, it's less annoying. Plus or minus 1.25. And I think with how much practice we've done, we should all be able to graph our completing the square, vertex form, whatever you want to call it. I think we should all be able to graph these problems at this point. Yeah, you're taking little formative assessments as we go along through those quizzes in Khan Academy. We'll take an actual summative assessment, like a wrap-up assessment, once we're done with quadratics. Quadratics is just huge. So I want to be able to throw all the various types of quadratic problems at you guys. And I want you to know all the strategies so you can choose how to solve on your own. Like, you choose whether you complete the square, or whether you, like, use a factored form, or whether you, like, you can choose based off your toolbox. You look at it and you pick the tool you want. I know. Welcome to high school math.
Also,
Yay!
like definite grade, like there's no math grade, right?
What?
It's confusing because it's high school, but it's also easy.
This will be taught mastery. Your grade will be converted to a letter grade. I will tell you along the way, if it's if it is of concern, mastery means A. You guys should all get A's, assuming you finish this class. I don't know that I can give A+. If I always say, if A+ is a thing, they get A+. If A+ is not a thing, they get A's. Like, I don't know that A+ is an actual, like, transcript grade. If I can give you an A+, you'll get an A+, if that's what you earned, Katie Ann. So, if we were asked, so now what we're actually talking about today, our new header could be graphing from standard form. I can't find my mouse. Literally, I have a mouse in my garage, and it's driving me crazy, but that is not what I'm talking about. It chewed a hole in my disc golf bag, guys. A shrew? I didn't even know shrews existed in Ohio. So, standard form is that whole ax squared plus bx plus c thing, right? So, standard form is when we have ax squared plus bx plus c pretty much always equal to 0, because that makes it quadratic. And in this case, so for our first example, we're given x squared minus 4x plus 5. Now again, we're going to start with an easier one that we would have multiple options, and then go from there. If I asked you to graph this with our previous knowledge of parabolas and quadratics, what would be your strategy? Nah. Yeah, factor it if we can, right? So making it into two binomials would be factor it. So if I think through, can I factor it? Positive C value, negative B value means negative, negative, right? To multiply and get a positive. To add. So I'm going to do this part in pencil because, well, this part. So 5, right? 4 and 1. Oh, wait. That doesn't multiply to make 5. Crap. 3 and 1. Crap. No, wait. 3 and 1 makes 4. But 3 and 1 does not make... Crap. Negative 4, and, but that makes positive 4 here. 5 and 1 makes... Well, 5 and... A negative 5 and a positive 1 makes 4, but that makes negative 5. Crap! Nah, I wanted a frowny face. It's a frowny face! You guys are really critical. Jeez. Dudes, so the irony of my life is really funny because my sister is literally in a master's program for art, like for graphic design, and like she will one day probably be like making the things that you see in magazines or as you walk by a store, like that art. And here I am drawing smiley faces and you guys are picking on me. So this sucks, right? If we're being straight up honest, this sucks. So we start to give you some nice little strategies. If we were being asked to find the vertex, here's a new trick. The x value of the vertex negative b over 2a. This, I didn't even have to ask the question. I love when that happens. I really wish we didn't have to wear masks because I think a lot is said by our faces. Like, dude, that just made me so happy. This is a chunk out of the quadratic. Right? Interesting. So, if that is the x value, okay, well, okay, so let's set this up. X is negative b plus or minus the square. So x is, we won't start the song, the opposite of b. I know it sounds better in the song to say negative, but really I want you to get in the habit of saying opposite of b. B is negative 4. The opposite of that is positive. Right? Positive 4. 2a, what's a? 1, right? So 2 times 1. So if we really, really wanted to write all the work out, we would have the opposite of negative 4. But either way, it just becomes 4 over 2. So, okay, my x value is 2. Great! Ah, wait. That's just the x value. What do we do from there? How? Ah, sub it in, right? Substitute. So if this is x, sub that into your equation. So, okay, y equals x squared, so 2 squared. And I'm just grabbing the equation from up here, right? Minus 4 times the x plus the 5. 2 squared is 4 minus 8, then plus 5. So we have positive 9 minus 8. We get 1. Woo! So vertex is 2, 1. Great. Where do we go from here? Couldn't you cheat? Well, I mean, they've got a point. If what we're trying to do is graph it. Oh, that was, finding zeros is easy. Like, that was what we were trying to do here, right? And this made us say crap. You're all trying way too hard. We had that! You guys keep looping me back to here. I think you just want me to draw more sad people. So, guys, if you went to graph this, imagine this. 2, 1, I know this point. Thanks, 8th grade version of Katie Ann. Guys, all I'm doing is asking, where do I go from here? Well, just go right or left. Make x either 3 or 1 or, I don't know, 4 or is it like, what we just did here was we took an x that we found and plugged it in to find the y. Why don't we just do that again? Just pick another x. So what if x is, I don't know, 3? Crazy idea. What if x is 1? Crazy idea. Right? We do the neighboring points. So that's our vertex, but let's solve for when x is 3. Now this is when, if you already plugged something into your calculator, you could just go back and change what you plugged in as 2 to a 3. Or you could think 3 squared is 9 minus 4 times 3 plus 5. So yeah, 9 minus 12 plus 5. So 14 versus 12. No, we get 2. Now wait, what do we know about parabola's behavior? It's oof. It's evil. Both of those things I don't quite know what to make of. Yes, it is bendy. That was the math word that I'm looking for. Parabolas are bendy. What's the S word? SY. SYM. It's symmetric, right? So this is also going to come out to 2. This came out to 2. This would also come out to 2. We don't need to go both ways. Just go one way. So guys, here's my advice. Choose the easiest option. 1, I think, is easier than 3. So we could have gotten our 2 from right there. But then 0, don't make y 0, make x 0. If x is 0, then we have 0 squared minus 4 times 0 plus, oh, well, duh. I feel silly. 3, 4, 5. Reflect it because my parabola is symmetric. And like we said, once we have 5 points, that's pretty much going to show us the behavior. And especially if we have a utility to help us graph it. You know, saying compliments in a sarcastic tone is just as bad as saying an insult. She can't even say it. Like, she can't even get the words out. You guys are great. You're my best friends. Just while we're being sarcastic here. Alright, so sorry. Any questions on what we just did before we try another more difficult one? Because you guys are mean to me and I might as well keep making things harder. But our thing in Worthington this year is say yes to the hard things. So let's say yes to this difficult math problem. Yes. Wow, we took a lot of notes in this class, guys.
I know. You should see my math on
Just like your soul. I mean, wait, what? I just remember Katie Ann saying something like that. It's empty like my soul. I was like, whoa! We got heavy really fast. Y equals negative 1/8 x squared plus 1x. I'm going to go ahead and put a 1 in front of that just to make sure my brain thinks about it. Minus 4. We said my x value is negative b over 2a. And we can sing a little song at the same time if we want. So if we use that rule, then x is the opposite of 1 over, oh man, 2 times a negative 1/8. Yeah, you're right. So first thing I'm going to do is say negative over a negative and just stop caring about the negative signs because 2 negatives will make a positive. I'm going to cancel that out. Then 2 times an eighth, okay, 2/8, so a fourth. Now how do we divide by a fraction? Multiply by its reciprocal, be careful, not opposite, just because that is I know what you meant, but it literally, like, mathematically means something different. So this is, it's 4. It's not as bad as we thought. You know, it's okay to say nothing. You don't, yeah. I really do like my job. He says directly to the camera, breaking the third wall. So, now what do we do? Yeah, sub it in, right? So substitute x equals 4 into the equation. So, negative 1/8 times, now, careful. The x gets squared before we multiply by the eighth, because order of operations, right? Exponents before multiplication. So I'm going to go ahead and do my 4 squared, but I'm going to, in this step, I'm going to write it out just to make sure I don't skip steps, especially because we're recording this for people at home. Luckily, my computer is not filled up its hard drive yet. So, sorry, I should have written plus 1 times 4, but that's how I get that 4, and then the minus 4 was there all along. Y equals negative 1/8 times 16. Oh, what's going to happen out here? They cancel. So what's negative 1/8 of 16? Well, negative, right? Something negative. 16 divided by 8. Negative 2. So our vertex is 4, negative 2. From there, pick a direction. I like to kind of evaluate what the numbers are and think, well, what might work easy? I mean, 2 wouldn't be terrible, right? 2 squared would be 4, and then 4 over 8 would be like a half, right? So I chose an x value of 2. Wouldn't be terrible. Sure. Yeah. Except that, yeah, it's probably going to be really high up and hard to graph. You probably want to go closer to your 4. 36. Can't divide by 8 nicely. So we would just go from there. I seriously think I would try an x of 2. Just because it's close-ish. So if x is 2, well, it's only 2 away. I'm going to go ahead and square it. Negative 1/8 times 4 plus 2 minus 4. This is going to be negative 4/8 or negative 1/2. Plus 2 minus 4 is a negative 2. So we get negative 2.5. Interesting. Well, yeah, because this y was just negative 2. Okay, Katie Ann, let's dance. You said make x 8. Well, this is really, it's not that far apart, right? Like 2 compared to 2.5, both negative. But okay, if x is 8, then y is negative 1/8 times 8 squared, 64, plus 8 minus 4. Ah, I see what you did here. These work nicely together. Negative 64 divided by 8. Ooh, careful, negative 8. 8 minus 4 is a 4. Guys, why? Why are our values of y barely changing? Give me more. Give me more. 1/8 is sucky. Give me more. What does a leading coefficient do to the parabola? Changes steepness. So what does a leading coefficient less than 1, don't worry about the negative, who cares about that? What does a leading coefficient less than 1 do to the parabola? It flattens it out, right? Not all the way, but it widens out the parabola to a point that, guys, if we graph that parabola, what's the negative do to it? What does the negative do? Flips it, and then it's like stretched out super wide, so it's going to be like, it is going to be bendy, but not as bendy as the bendier parabolas. To use your brilliant vocabulary words that we've coined in this class. So I now have a few points. I could reflect these points because the parabola is symmetric. And we have 5 points here, right? 1 vertex and 2 other points that can be reflected. This is 5 points, even though I'm only showing 3. The other point here, if x was 2, it went 2 down. I can also go 2 up. So x being 2 is the same as if x was 6, right? This would also lead to the same y. It should, at least, if the symmetry works. If x is 8, that's 4 above. So I can also go 4 below. That should also line up with x being 0, actually, should also lead to that y. So if the symmetry, which I'm saying if, but we know it works because it's a parabola, if the symmetry works out, these will also be x values at that y value. Yep. Then it's not a parabola. I mean, so something broke. Really, something broke is what happened then. Like, it either wasn't a parabola to start, like maybe you were operating thinking it was a parabola, but maybe it's actually exponential, or maybe it's actually like got some piecewise growth where like it was parabolic, but then it breaks. So you would need like domain restrictions if something weird was going to happen. This is a parabola, right? We know that because the form it's written in, it will be symmetric. But let's say you were working with something else that didn't start with just straight up giving you a trinomial. You wouldn't necessarily be sure that it's a parabola. If it's not symmetric, it's not a parabola. There's your easy answer. So. No. Well, I was about to check the schedule, and if it was time to go, I just, then I can get out of searching. Fine, I'll search up Ombre. How do you spell it? Okay, it definitely sounds made up then. Because Umbro, that's a hairstyle. Yeah, I know. I was talking about Umbro was a soccer. I feel like somebody just took the word Umbro and changed it. A trick-taking card game for... Wait, Katie Ann, now you got my attention. We're talking about a card game? Woo! In the 17th century, Katie Ann, I didn't know how cultured you were. You play 17th century card games? I didn't see that at first. I didn't intentionally ignore that to talk about a card game from the 17th century. Oh, man. If only Google was... Why is it called Ombre? It's French, Katie Ann.
I know, I'm so fancy.
So, generally, ombres work best in brunettes because it's the least subtle of all. I don't think this has to do with your water bowl. Alright, with that, all my blue people, hopefully you had a great day and enjoyed being a fly on the wall in whatever this just was. So my friends were on a podcast, and at the beginning of the podcast, part of the intro is this episode and probably this whole thing is a mistake. And sometimes I feel like that with your guys' class. Is like, this lesson and probably this whole thing is just a mistake. Umbro. UMBRO is a soccer company.
Oh, yeah.
That's when you guys say ombre, I think of Umbro. Like the old soccer company. Alright, we're going to stop this recording now. Have a great day, guys. Email me if you need anything.